Here we have an exponential equation and we have to solve for x in this exponential equation. Okay, first let me write the given exponential equation as it is. That is 36 to the x to the power negative 6 to the x to the power over 6 to the x to the power equals to 5. Okay, in my next step, what I'm going to do is I'm going to write this 36 as 6 square because 36 is a power of 6, so it can be written as 6 square. So since we write 36 as 6 square and whatever exponent we have for 36, the same should be taken for this 6 square. Then I'm getting 6 to the second power whole to the power of x negative 6 to the x to the power over 6 to the x to the power equals to 5. Okay, now let's consider an important property in exponent. Let me consider the base a with the exponent m. Again, for the whole stuff I'm considering the exponent n. So whenever we have two exponents like this, what can we do? So we can do it in two ways. That is, one way is we can multiply these two exponents, that is a to the power m times n. So there is another way to do this one, that is I can switch these two exponents. That is, I can take this n as the first exponent, m as the second exponent. In that case, I'll be getting a to the nth power whole to the mth power. Okay, now I'm going to follow the second way over here. So that is, I'm going to switch these two exponents 2 and x. Okay, so when I do so, what will I get? I'll be getting 6 to the x to the power, then whole square negative 6 to the x to the power divided by 6 to the x to the power equals to 5. Okay, so here we have 6 to the x to the power, 6 to the x to the power, 6 to the x to the power. So to make the solving process easier, I'm just going to take a new variable. I'm going to substitute a new variable for this 6 to the x to the power. So let me assume y equals to 6 to the x to the power. So at everywhere in this equation, I have to replace 6 to the x to the power by y. So if I replace this 6 to the x to the power by y, then I'll have y square for this one and negative. So for this one, I'll be getting y, and for this one, I'm getting y equals to 5. Okay, so from these two terms, I can factor y out. So if I factor y out, what will I get? What will I have left in the first term and second term? So for that, I have to divide the first term y square by the one I factored. If I divide y square by y, what do I get? Y square can be written as y times y over y. So this y will cancel. I'm just getting y. So when I divide the y square by the one I factored, that is y, I'm just getting y. And now to know what I've left in the second term, I have to divide that y by the one I factored, that is y. So y divided by y is just 1. So when I factor this expression over here, I'm getting y times y negative 1 over y equals to 5. Okay, now this y and y can be cancelled out. I'm just getting y negative 1 is equal to 5. Okay, now what I need to do is I have to solve for y. Once I solve for y, I can solve for x because my aim is to solve for x. To solve for y in this equation, what I need to do is I have to add 1 to both sides. When I add 1 to both sides, this negative 1 positive 1 will cancel out. I'm getting y is equal to positive 6. Okay, let me take the equation over here. Y is equal to positive 6. Actually, y is a variable taken by us. It has to be replaced by the original stuff, that is 6 to the x to the power. Okay, now let me replace this y by 6 to the x to the power equals to 6. Okay, here on the left side we have base 6 and exponent x. On the right side, we have base 6. What exponent do we have for this 6? Actually, the exponent is not mentioned over there. So whenever there is no exponent for any base, we have to assume there is exponent 1. Okay, now the two terms are equal with the same base 6. So whenever two terms are equal with the same base, what I can do is I can equate the exponents. When I equate the exponents, I'm getting x equals to 1.